The birth of APQP happened at Ford because Ford was one of the first persons who were wanting to scale up production at a crazy pace. In his own lifetime, he wanted to have more than 2,000 workers in a single assembly line. And so to maintain quality of a car, question came that
Hmm.
how to maintain the quality. I got exposed to additive manufacturing and I realized at that point that technology of the old is never going to be better than the technology of new, because ultimately anybody can learn mechanical engineering concept, but it is very difficult to drive in a mentality, a passion to solve a problem which is probably difficult to solve. If you actually want to identify the problem clearly, define it clearly, identify a user base clearly, and then understand the requirements to solve it only for them, it is going to take 2 years. You can't do that validation of the problem without involving the user on day zero. If you are thinking that, okay, this is a problem and it will have a demand in the market and I will make the design such that the demand will be by that per month, that is going to be delusional.
You have to get the problem validated. You have to get the initial solution validated. It has to go always be in collaboration with the user, or else you're gonna build something that nobody's gonna use. It's, yes. Okay. Yeah.
Right.
Thank you everyone for showing up. My name is Anishay. I'm from Exclusive Magnesium. So we are doing this effort to try and talk to design engineers and people from the mechanical engineering background because we want to understand that side of things a little better. And for the same reason, actually, today I'm excited to introduce Cassian Mario John. There's a lot that
Yep.
he's done. He's accomplished a lot, but I'll just try to cover the basics and I'll link in the rest of his complete experience in the description anyways. He's obviously from the mechanical engineering side of things, but recently he's turned more of a manufacturing systems builder. We'll talk a little bit about that as well. He's a true believer in continuous improvement, and we will cover that as well. Just to talk about a little bit about your education. You did your education from University of Mumbai, and then also
Yes.
you did your master's in tool design from Osmania University, and you're currently doing a post graduation in data driven decision making from IIM Trichy. So that's very
Yes.
impressive. Yeah, I think back in college itself, you started something called Xanthiam Racing.
Yes.
I think that sounds like the earliest R&D experience that you had. So I want to start there right away when we start. But I think after that, you did your research in conformal cold tooling.
Yes.
You started your career with Turnkey fire protection systems, then moved on to additive manufacturing. And I think you've done a lot of specialized toolings during the COVID time as well.
Mhm.
I think the last 4 years you worked with Futuristic Labs as a senior R&D and quality and procurement side of things.
Yes.
And where you contributed to the semi-induction cooktop. That's the one that you worked on. And then Rico rice and curry maker. I think where you both took them from pilot to scalable manufacturing, which is impressive. On the procurement side of things, I think you have done a lot of work with reducing lead times. We'll talk a little bit about
Mhm.
that. I think your current gig right now, where you're working as the technical co-founder for the Indian Shroom Company, and you are developing integrated sterilization and drying technology and trying to scale that supply chain towards a 1 crore target over the next 2 years, which is, yeah, that's an ambitious project. So anyways, we'll talk all about this over the conversation. So Cassian, welcome.
Thank you very much, Anisha. I'm very happy to have been invited by you. I think it's going to be a fun conversation talking about everything that you just mentioned.
Yeah. Cool, cool. The first thing like I mentioned, I wanted to focus the initial part at least on the product R&D mechanical side of things in this interview. So let's start early. I think Xanthium Racing, is that the first
Yes.
R&D work that you started doing? So take
Yes.
me through that journey. What was Xanthium Racing about, and yeah, any lessons that you learned during that time?
Okay. So the Xanthium Breakthings is literally the beginning of where I would begin to make my ideas come to fruition, right? The first opportunity where in a college where it was a dream to build a car always as a kid. So the first opportunity that life presented to me was that either you choose to attend lectures and only get marks, or you try to do something new in your college which was not done before. And the goal was to we were a college which was having two batches of mechanical engineering, but all other batches of IT, computer science, electronics and telecommunications, we were all one batch each only. So we were 120 of us, and there was no active projects being taken up by the college. There were not too many companies that would be coming in to offer internships or anything of that sort. So when into in my second year of engineering itself, I wanted to make a car. So we went and got our college associate club SAE for Don Bosco registered, and we began Xanthiam racing with the goal of having at least 20 to 40 students participate in three major competitions. One was a go-karting competition in NGKC. The other is a Supra SAE event where you build a 350cc Formula One styled single-seater car. And the third event is the Baja SAE, which is all three events are fairly still popular in the engineering colleges. And it's one of the few events where students get a chance to actually do hands-on R&D, actually understand why they have to study all the subjects that they are studying, right from selection of materials to, which is one of the very critical yet boring subjects, traditionally speaking. But the materials engineering and understanding how to put components together, what fits against what, not just about the selection of components or imagining or dream building a car that looks a certain way, that is colored a certain way, but a lot more of the ground engineering where you see why this engine, you have to justify the engine selection, you have to justify the suspension setup, you have to justify the materials that are being used for safety purposes as well. So that was a definite what my first R&D concurrent engineering kind of experience, where we had to rope in students from other branches and we had to work together, integrate different systems together, which requires expertise from different backgrounds. So that was definitely a first experience to working with different cross-functional teams. And definitely we put out a car. It took us 2 years time and a lot of funding, but like self-funded itself, obviously. But the learning from there was right from something as basic as, okay, how many varieties of steel are there and what are the grades that Indian traders call them? What are the same grade equivalent that other traders call them also? Even something as basic as that, we had to learn it only because we had the practical opportunity to go out into the market and ask about these materials, find out the cost, what is the difference in machining each different grade, because it is a very different thing to see in a tabular column or chart. These are the material removal rates of different materials, this is the hardness values, but then to actually understand how it translates into a real world challenge. Why are those numbers critical and important in understanding selection of material, selection of manufacturing process? It all began there, definitely. And but soon after that, experience of that was very much core technical and it was all students working. It was very much cohesive from day one for those who were passionate team members. We were already wanting to do whatever it takes to get the best solution possible. But soon in my first job, setting the turnkey projects where we were in fire protection system, involved us to work on very different engineering level. The project was running on a timeline, 2 year timeline, 2.5 crore budget, and the initial budget that was approved was only 1 crore. You are working with a team of probably 70 to 80 laborers, around 10 to 15 engineers, out of them, most of them being on-site engineers, a few others being consultants and designers working with the client BASF to figure out the pipeline network and stuff. And that was a very different experience where understanding project coordination, people management, and contract management was something that I wholly solely understood there. And that was my first exposure to understanding how supply chains also work, because we had to have multiple vendors for various different components, accessories that were to be installed on site. And that experience was completely more into the project management, construction management side, which gave me the necessary tools as a mechanical engineer to understand management in general as a practical hands-on experience. From there, I think soon I wanted to have a technical game up, like a level up in my game for specifically in production processes, manufacturing processes like injection molding, die casting, sheet metal forming, etc.
But
And I wanted to learn that because I had a passion and an interest for making and building and creating stuff. So building something at mass scale at 10,000 units a month was very
right.
alluring, and it was very right. While studying and pursuing the master's course for tool design, I got exposed to additive manufacturing, and I realized at that point that technology of the old is never going to be better than the technology of new. And I started embracing a lot of the newer technologies that were there, and I got a very keen interest on how to apply the new technologies for solving old problems. So the problems may be old, the clients may be new, but with the same old problem. But if you add a new dimension of thinking by either adding a design tool, a new design tool, a new manufacturing tool, or a new manufacturing technology to create a part which performs the same function, but because of the added new features in design and technology, it may just perform better. Therefore, I came up with the project of wanting to do conformal cooling inserts or injection molding of components in the, let's say, pre-production stage. A lot of companies require bridge, what we call as bridge tooling. When you go from producing 100 pieces in one set to when you want to just produce 1,000 pieces, but you want to still protect the mold for future upgradation or making it a hard tool. That was definitely a project that was driven completely on simulation and you see all modeling completely on digital software, creating digital twin of a mold and seeing how the part would cool in a given molding setting. It has to cool uniformly being the goal. And post that, I think Futuristic Labs was a transition into a complete core NPD, NPI kind of
Yeah. So
cycle.
let's go till here because futuristic labs. I think you did a lot more from scratch to manufacturing. So let's cover the early years that you spoke about. One fascinating thing that I realized is that the best engineers that I've ever worked with have all worked in some form of racing team in college. It's a unique coincidence that I've come across that I don't know if even the Aether founders actually they themselves were part of these teams. And then when they hired their early hires, they were all from these racing teams. So I found that very fascinating. And even the engineers that I work with that I hire, I have a bias towards people who worked in racing teams. And they have a step ahead by at least 3 to 4 years on their peers who've not been part of these teams. So I think that's a very good experience that you got early on.
Yes.
Yeah. Do you think this something that is going on all across India sufficiently, or do you think there's more that can be done in having
Well,
such racing teams?
okay. So in my limited experience, let's say, I have met many more like me who have participated in such events. I have met them outside of college, obviously, 2, 3 years into the industry, meeting them at exhibitions, events. You find out about these engineers and then you ask them, okay, you'll introduce yourself. This is where you're currently working. This is what we are providing services and so on. And then when you're trying to understand more of or trying to justify whether what they are saying and how closely to true is it going to be, because the ultimate thing is that when you know that person has also been a part of racing team and that's the reason why they are in engineering, then you have an immediate correlation of the understanding key. The person in front of me is just as passionate as I am because we can relate to that core value of the reason or like why did we join a racing team in college. We had options to do other things as well, but to be a part of a racing team meant to be a part of a mini company within college who is doing everything. We are going around people for asking funds. We are having meetings to decide how to do the budget.
Yeah.
We are doing that from a very early age on, and we know that whether it is to build a car, whether it is to increase your production, whether it is reduce the defect rate, if it's about making something that is better than yesterday, then it is serious business, and it's not going to happen with just the jokes around, or it's not going to happen with the light-headed mindset. So when people go hiring into the modern industry, I'm not surprised. Even myself included, when I did hiring, it played a heavy role into understanding what kind of project that students would engage themselves into, because then that it would very
Mm.
easily reflect our ability to match with them in culture, or like how when they integrate into our corporate culture when we are hiring them. Will they be able to will it take them more time to get the right kind
Yeah.
of passion required to solve the problem? because ultimately anybody can learn mechanical engineering concept, but it is very difficult to drive in a mentality, a passion to solve a problem which is probably difficult to solve. It is
Yeah.
not a single person solving a problem and getting a Nobel Prize kind of situation in mechanical or team engineering kind of situations where everybody has to think together. It requires a certain nature in an individual to be objective, to be socializing as well, to be candid, to be open and honest to what they know themselves, to understand and respect what others also know, and then brainstorming what needs to be done next. So these kind of qualities are extremely crucial in environment, modern workday environment, where even a mid-level manager who's having 3 to 5 years experience also will have one intern at least under him, and it is expected out of him or her to get the best out of themselves by getting 2 people or 3 people to work together cohesively as a team. So that is the maximum value for a company's employee. So in order for that to happen, they need to have a proven history in 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 putting their value while being a team member, irrespective of their post in the team. It's their drive and passion that drives their knowledge to give a good idea, to give a good alternate solution to a problem that they are thinking.
Yeah.
Then also having the energy to be able to do it consistently is very key. Like I said, the car took us 2 years to build as college students. And little did I did not realize at that time. I thought that it's because we are students that it took us 2 years. Other people would have finished it in 3 months or 6 months. But now I
Mm.
realize that it doesn't matter which product you try and take to solve. If you actually want to identify the problem clearly, define it clearly, identify a user base clearly, and then understand the requirements to solve it only for them, it is going to take 2 years. Nonetheless. It is going to take 2 to 3 years time for any idea to evolve into a scalable product. So that was the whole challenge of SEE itself. SEE has been conducting this competition for more than 20, 25 years, and
Mm.
their booklet or their technical guide changes very little. But they know that it is going to challenge students to build a car, a single seater car. Nonetheless, again and again, competitively, they'll be able to judge them because it is difficult to make it within 1 year. It is difficult to make it within 2 years, catering to that driver's spec, catering to the performance limit. When you're trying to fight for a second, in a lap time, then definitely it will take minimum 2 years to get to that point. It's not a fictional thing to say that people who have done team-based projects in colleges work well in corporate environment, especially if they are passionate for their job and their domain of engineering. Then definitely that will play a big part.
Yeah. So I totally agree. The kind of when you're doing teamwork, solving a problem, and I think the experience that this gives when you're working on a massive engineering project as a collaborative team with multiple aspects of funding and everything, you become you as an engineer also, I think you would end up being a lot more thinking engineer and solving problems which seem impossible to solve probably initially and then slowly getting to that solving stage. So I think that's a brilliant experience. I never got to do it because I was from the material side of things and our projects were way more boring than building a car. I wish we had in our college a project like that would be so much more fun. I see a lot of drone projects that people are doing nowadays to as a smaller version of the same thing. I think building a car is a lot more complicated. I think we should continue doing that. But anyways, so let's move to the next experience that you were talking about, the one about tooling. I'm very interested in tooling because you took that leap on towards designing tooling, which is a very niche area. And
Mm.
not too many engineers work on that. And when they work on it, it becomes a specialty, right? So I work with tooling engineers all the time. You were working on injection molding tooling?
Yeah, mostly injection molding tooling only. And in both my previous experiences at Himgiri as well and at Futuristic Labs, I've done design tooling work. So
Okay.
Futuristic Labs I took one project of tooling completely on my own, like where the tooling design also to a great extent, I worked along with the vendor. But in the Himgiri additive experience, soon after my master's, there the tooling design was completely end to end me. So the tool was designed and in 2D and 3D by myself. Then we only had a machinist to get
Hmm.
to get three plates machine, and we got the EDM done. and we fitted and assembled the mold at another molding facility separately. So there I did the entire tooling end-to-end design, right from the part design to also the tool design as well, and required simulations that are done. In Futuristic Lab, we had two different projects. The induction cooktop semi that
Right.
we talk
So yeah.
is a three tools in total there. And the other Riku project, three tools for semi, we designed it collaboratively with our molding vendor. So there it was more on the design and also correlating how the tooling design can be optimized to meet product requirements, but without increasing cost, without increasing tool complex. So I definitely aided the tooling vendor also at that time, again with simulation and deciding what would be the correct material selection for the tools itself and the part also. But
So in
the
these cooktop,
bigger project that we had taken definitely was at Futuristic Labs was for Rico, but that was a much larger complex machine with more than 100 plastic components. That tooling project, I had taken that tooling project up with several white box builder, or what we call as turnkey box builder. We can call them people who take an idea and make it still scaled assembly and production. They take up the whole project. So we were collaborating with vendors there to do the tooling design for the Riku project. And I was the manufacturing and quality design head at Futuristic Lab for coordinating with these vendors for all part related and tool related design and approval. Tool design,
so I
you
was
wanted to?
wondering, with Rico and Semi, were these the cooktop version that you did? Were they all injection molding parts, or were they also die casting?
So the induction cooktop, everything was injection molded only, and one component was rubber molded, so it was compression molding. In Rico, it was more of a combination of injection molding, compression molding, which is compression molding. Also, you get two varieties. You get either bulk molding or you get sheet molding. So we mostly were in the bulk molded components. You especially rubber components which are over molded on steel also. Those kind of components were major in Rico, and very few were 3D printed, let's say. In polymers category itself, there were around 120 components was there approximately. Yeah.
I think you wanted to do something that at scale, and I think this was your direction that you took. That okay, I wanted to specialize in tooling because you studied tooling separately after your college. So
Yes.
yeah, so you wanted to be in something like a mainstream production process, and that's why you chose that.
Actually, it's a good question, but I've thought about it for myself, how I came to this decision. Retrospectively, thinking that I purely joined this course because of only two things. Because I got the confidence by looking at the curriculum and the history of the institution, that this institution has given the Central Institute of Tool Design in Hyderabad
Right.
has been a hub for between 1980 or between 1975 to 2005 for 30 years. It has been the hub in India at India level for generating or putting one of the best entrepreneurs in India in terms of manufacturing industrial entrepreneurs. Vasanta Toolcraft, Quick Dies, even a few key personnel in the mega engineering also. All of them passed out from CITD, and they started their businesses in press tooling, injection molding, CNC machining, all these areas from ground up with nothing backing up their pockets before. You see, and they started all their businesses as engineers, started passed out from this institute. They all were tool designers only, and it was my thinking also that if I can learn tool design to design tools on my own, I could definitely, if nothing, if not a job also, I was very much keen on keeping a single shop with one multi-axis CNC machine, so that I can offer mold machining services also and design and develop molds of my own, so that there are several parts, several products, domestic products in the market which sell out in high volumes, yeah, at low margins, but very high volumes. So I wanted to do something on that end, so where I can own tools and produce parts from them and sell it or at wholesale. It was not about becoming a tooling engineer or a CAD CAM engineer. It was always about learning tooling design with the end goal of using it to build a business. So right now I am with my experience, I've had a good opportunity of working for a few proprietors or startup founders directly their core team to deliver on products going for tooling, first phase tooling, bridge tooling, and then hard tooling. So going from even something as simple as vacuum casting, instead of tooling directly, you do urethane casting or vacuum casting with silicone mold, epoxy mold, aluminum molds, and then we go on to using steel mold. Everyone, irrespective of what product they are making, depending on the manufacturing process, your volumes will determine your cost. If your demand is there in volume, that will determine your cost, and that is the main key factor that will drive towards selection of a manufacturing process. And if your selection is wrong, that means your demand forecasting or your demand input for itself was wrong. And understanding not just the demand, obviously the part complexity and the requirements of features and the function of the part as well. But any of those requirements can be replicated at least two, three different manufacturing processes. But to understand it in the right context would require you to understand why those cost benefits are fluctuating with different manufacturing processes. So in order to understand that fluctuation, that connect between the technical features and the economics of any given mass production process, I wanted to learn tool design. I wanted to understand what makes different manufacturing processes at different costs. Let's say a
I feel
casting,
like
like a casted part, for example, would definitely require a post machining jig or fixture if it is having a complex feature set and you want holes to be reamed or you want the edges to be cleaned, things like that. So it would require a CNC fixture, which may not be the necessity in a plastic injection molding tool. So these are the kind of differences that only a core tooling engineer will understand when we're looking at a part. So I wanted the same understanding, same level of understanding so that I can use it. I hope that answers what you.
yeah, absolutely. I feel like your approach also, if I look at your early career, I think already you were looking at your education itself very entrepreneurially. So you were trying to become, you were taking a very entrepreneurial projects right from that racing. If you look at the tooling, the way you mentioned that you wanted to build like these small toolings and create a product and in wholesale sell it off. That's a very entrepreneurial approach to think about your education. So I think that's cool. Let's get more into the R&D side of things that you did with the cooktop and the curry maker that you did. Tell me more about the Futuristic Labs that you did, the R&D side of things first.
Okay. Futuristic Labs was a very unique experience, and I'm really grateful that I took that opportunity up and I got that opportunity in 2020. And when I joined them itself, it was very clear that it was a young organization that was attempting to solve the problem of cooking. The problem in cooking, what is the problem with cooking? The regular complaints that users have, it is too complex, it's too time taking, and it is never repetitive. Means we as cook in our home, if I make egg
Yeah.
every day it seems to taste different somehow.
Yes.
So if something as simple as just egg can taste different, something as simple as Maggie can taste different. So we were trying to tackle that by producing a product which enables people to cook with guidance. Cooking with guidance or guided cooking, it was the major USP of our portfolio of products at Futuristic Lab under the brand called Clean. The first product is the smart induction cooktop. The unique features separating this from what you regularly get is that number one, it was the high power cooktop. It was 2000 watts. Second was that it had a inbuilt temperature sensor. And third is that it has a wing sensor to determine the weight of an object that's placed on. So in order to, it would basically detect the weight of ingredients in the guided cooking mode. It would ask you, okay, take 1 kg of onion. So you could use it to weigh the 1 kg of onion before chopping them. Or if you already had chopped onions, if you want to know, is it 800 grams or 1000 grams, you could put faith on it and weigh it. Considering that particular product, our R&D process in a startup environment, we have to get everything right the first time. That is the attempt. The correct quality at the first time itself. First time quality in prototype, first time quality in digital prototypes and hardware prototypes, first time quality with respect to what we had previously defined. The product and the prototype will not be perfect the first time. I'm trying to say that the prototyping, what you had thought to make, that only should have been. What we had defined as a requirement, that should have been fulfilled. But if the part does not fulfill the function, it means that the requirements were not complete in the first. It means that the requirement were not defined completely in the first. The approach, therefore, in our R&D labs was a completely APQP driven process, advanced product quality and planning. That is the full form. APQP is a methodology. It's a fundamental philosophy that is followed, that has been dictated by the top quality organizations in the world. ISO themselves, along with a few other organizations, they are the international quality organizations. They release this APQP manual every few years, every 3 years or so. And we had access to an older version of the manual, which is, let's say, available. It's free of open source. We use that to say that we are here defining the problem, and this is what we conceptualize the design to be. And this concept is talking about a particular system. It has subsystem, it has function, sub-function, and then finally it comes down to assemblies and components. So in that structurized manner also, in order to develop a product, the APQP guideline clearly states to go from the customer need, identifying customer need, identifying customer problem, to identifying their requirements, understanding market requirement. Those requirement analysis, we go on to system engineering, concept designing, and all the way down till mass production. There is like a very, very established 21 point kind of step process, which is take as a guideline. You can do all 21 steps, or you can expand those 21 steps into further steps based on what is your organization need and expertise.
So I had two
For
questions
that
at this
industry,
stage.
yeah.
So I had two questions. APQP that you mentioned, is that like a generic thing that is available publicly known, or is this something that was developed in the company? Because
No,
I'm not from the
definitely.
product side.
So the birth of APQP happened at Ford, because Ford was one of the first persons who were wanting to scale up production at a crazy pace. In his own lifetime, he wanted to have more than 2,000 workers in a single assembly line. And so to maintain quality of a car, question came there, how to maintain the quality when different laborers or different workers are tightening the same bolt. How will the bolt remain the same at the same torque if different people are tightening it? How will the electronics be assured that the connections are made correctly if different people are doing it? If a senior technician is doing it, it may be different. If a junior technician is doing it, it may be different. Who is checking it? How to verify? How to validate? So all of these questions gave rise to a manual. At every step of the process. And the manual initially was focused only on the production floor. But then so many questions start coming out of the production floor. And then they're asking questions of the marketing department. Why is the color like this? Why is the mirror shaped like this? This is making it difficult. Why you'll ask questions of the design department. Why is this seat weighing 25 kgs and my man cannot lift it and keep it in the operating line? Reduce it by 5 kgs. Anything can come up. Any requirement can come up from the production floor, because that's where you're actually building the product. That's the interface of answering everything. Whether if something is going wrong, you'll be able to answer it there. Even if after the product has reached the customer's facility and he's using the product, whether it's a car, it's a home appliance, it's a laptop, it's a headphone, it can be as small as a watch to as big as a car. Any of those products, if we have taken it away and after 6 months of use, if a component has worn down and it has come to the service center saying that a component needs replacement, it will go as a notification to the company and say that this component from this model built in this year needs replacement, and the company might be in a position or not be in a position to say, yes, the time is up, it is correct for replacement. Or second, they might realize that a component that is not supposed to be failing, it's failing. That means if that component is failing with that customer, we may have 1,000 other cases which are not known to us, and we might be incurring a cost or a negative feedback in terms of product performance, because we did not know that this component is failing beforehand. So all these things combine together, and if you find out why it is failing, it will either be the way it is made, will be based on what material is chosen, it will be based on how many user requirements were taken in place, and it will be also important to check whether all the business constraints were also taken into consideration while releasing or approving this particular component for production. APQP in Ford was developed for catering across all departments, asking the right questions across all departments in a systematic planned manner so that you can go when they call it gate in APK. You call gate 0, gate 1, gate 2, gate 3, and gate 4. Final gate 4 is essentially for life where you're continuously improving the product for life in billion when you're producing in billion. That's gate 4 if you reached billion. Gate 0 is when you're starting to define the problem, when you don't know anything and when you have very less user feedback of how your product is fulfilling the problem of the user. That's gate 0. If you're finished MVP, that's finishing gate 0. Finishing
Okay.
the minimum viable prototype or most viable prototype you complete, that gate 0. And gate 1, or gate 2, or gate 3 are subsequent progresses. You've got engineering validation, design validation, and production validation tests that you would
Right.
do, which would
And gate
slowly,
4
essentially,
beyond.
you're,
Yeah.
you're scaling up the volume also, and you're scaling up the features also. Like at the beginning, when you're only making 10 pieces, that 10 samples and giving out to user will be like at 70% of fulfilling all the requirements of user. But as you go towards 100 and 500 pieces, your understanding of requirements of the problem and what the user requires to solve the problem will go from 70% to 90%. The 90 reaching 90% is very easy for any product, whether it is in terms of design features, manufacturing process, materials, cost. Reaching 90% efficiency is fairly doable within, say, the reasonable 6 months to 12 months period for any given product of small to medium complex. But but if you want to go from 90 to 95 or 95 to 99%, it may take you 10 years and it will still not complete. That I think a very good example we can take here is spark plug in bikes. Spark plugs in bike, or even for example, I
Yeah.
think what you would be interested to talk about is the casted alloy wheel of automotives. The evolution of casted alloy wheel has gone from casted iron to what we have as casted magnesium today. Some evolution happens over a longer period of time, but some other evolution can definitely happen from 0 to 70 and 70 to 90 by following APQP as a fundamental process, as a
Yeah.
fundamental way of thinking.
One other question I had about this is how early do you bring in the user, the end user, into the conversation? Do you have conversations from day one, or do you bring them in during prototype, or what's your thinking on when does the end user come into the picture in terms of product development?
Yes, I have heard this question many number of times, and my answer usually is that there is no day one when it comes to user. It's always starting at day 0. If you are thinking of a problem, you are thinking that there is a problem, then in that conversation itself, you need to involve the user. You need to validate whether there is
Absolutely.
an actual problem or not. You can't do that validation of the problem without involving the user on day 0. If you are thinking that, okay, this is a problem and it will have a demand in the market, and I will make the design such that the demand will be by that per month, that is going to be delusion at
All
times.
hypothetical. Yeah.
Yeah,
Yeah.
unvalidated. So involving, that's the whole beauty of APQP. Is that we as designers, we as technical engineers, we understand materials, we can design, yes. But if we don't cater to the user, whatever we design will go waste. It'll go for a waste.
Yeah.
We have to involve, either it could be the client, it could be the client or the user themselves. But many times it will be that it is not the client who is the direct end user. We have to talk to the direct end user to understand what you need in the product. And on day 0 itself, and you do that from day 0 till the time you complete design validation. You involve them in gate 0, gate 1, gate 2, till the time you complete gate 2. You do not let go of the user only. Matlab, whatever they say, whatever they feel, and whatever their insights are, they are irreplaceable. They are invaluable. If you have qualified them as a potential customer, then everything that they say, then everything that they specify is crucial to product development. Every statement
Right.
that they make directly goes into the document called voice of customer. And it's only from there that you can convert their voices into engineering spec. They
Yeah.
will say in common
Absolutely.
terms.
No, I feel
We have
like
to
that,
convert them into engineering spec.
it's fascinating that so I've worked in services, I've worked in these kind of more product side of things as well. And I feel like I was initially skeptical whether hardware works in the same way. And it's obvious that these principles of product development, no matter which industry, what sector you're in, they are universal. You have to get the problem validated, you have to get the initial solution validated. It has to go always be in collaboration with the user, or else you're gonna build something that nobody's gonna use. It's
Yes,
essentially just that.
and
Yeah.
exactly.
So we have a shortage of time. So what I wanted to do is close on the experience that you with Futuristic Labs, because I want to get to Indian Shroom Company as well. Yeah, cool, cool.
Yeah.
So let's getting back to the Futuristic Labs. Tell me about how that experience was and what are the major lessons you got from there.
So with semi, the induction cooktop, we had made three molds, and understanding how to build a product which you're designing a product which that design is going to stay in the market for 4 or 5 years. Means once you create the design of the plastic, you're mass producing the plastic in a hardened mold, then you expect for the design to stay unchanged for at least 2 to 3 years, making a sales of upwards of 1 million pieces somewhere around. And then you would probably think about redesigning or rebranding or releasing a newer version into the market. For different companies, it can happen at different times. But my learnings there were especially that that apart from the point that yes, we have to keep customer always from day zero involved, and every till the time the product is matured can only be qualified whether it's passing gate 2 or not. In quality, we say if anything is stamped QC and okay, then you can't revert. There is no reverting back. Once it's stamped and approved, it has to go forward. So that stamp and approval had a very important value, which is something I learned at Futuristic Labs. Whether people will come and go in companies, employees, engineering teams will keep getting rebuilt, but the work or the progress of a product can only be determined on paper. It can only be determined on its ground reality of how it's performing in the market, what is the cost of making it as of today, what is the cost of shipping it, what is the reliability life of it, what is the warranty we are able to offer as of right now, and improving on these parameters is what is important to be tracked as the growth of a product. When a product is going from prototype to a scalable volume, then definitely these are the parameters that any team would have to focus on. And at Futuristic Labs, therefore, we learned those lessons the hard way. We learned those lessons because there were definitely gaps between our strategy and what the real world reactions were to our product launch, to our product features, to even say the color options that we are providing in the model. Even that was heavily dependent on the user, on the customer, and the market giving us the feedback so that these metrics that we keep talking about in terms of cost, margin, volumes, all those get validated constantly. And I think that's something that we as companies can do a little faster. We tend to wanting to verify and validate it, and we think of verifying and validation as a one-time thing. I did it last year. I did the verification and validation last year, so that cost should be good. I inquired raw material costs of casting last year, and I use those same costs this year for my new order. Things like that, and or even I have already done this validation earlier from 3 users or 10 users, and 10 users gave me positive feedback. So I don't need to do that verification again. That is a very false thinking to have, irrespective of where you are in the product lineup. If you want to know what is the next thing to innovate in the product, you need to constantly be in touch with your consumers. And it's actually more valuable to have a good set of at least 50 to 100 customers with whom you are constantly engaging from day zero, from the initial launch of the product to even model number 2, 3, 4. You're keeping them along the journey of the iterations of products that you're having. So they'll have the best insight as to seeing, they'll have the perspective to see where the product was on launch day one versus 5 years later, now the same product with features, how different it is feeling, and what new features can further be added. Users can always give you feedback. And the quicker you have that feedback, the more agile you can be in deciding with your design team as to what should be the next design goal. If you spend too much time in verifying and validating like once in a while only, the feedback is very slow in term, and feedback is far spread out, not happening frequently. Then your design teams also will give a less productive output in terms of the design feature. So I'll give you maybe one example here. Like I told you, we have a weighing feature in MI, which is an induction cooker. So it is already a flat surface, and integrating a weighing scale into it is not too far-fetched an idea from an engineering point also. And from a consumer point also, a weighing scale looks pretty flat and you just place on it and there's a display and you can read in gram or in kgs what is the weight. Pretty much that's the user interface also here in this case. Use case is only the use case was different when you're using this in cooking scenario. Now,
Right.
when we went to apply the same logic in the our other product, so the automatic rice and curry maker, implementing weighing in an automatic cooking machine where you expect the idea to be that the user is just loading ingredients, the machine is cooking on its own. So
Right.
this required the machine to understand and determine on its own how much ingredient is placed by the user. Is it 100 grams of onion? Is it 200 grams of chicken? So in order to know what is the weight of the ingredient required, we had to incorporate a weighing system in the. But while incorporating that, we could not afford a long timeline of customer testing at our initial concept prototype stage. We did a very short exercise and we moved on to the functional prototype. Again, we did a very short exercise with even lesser users, and we very quickly moved on from functional to even the design prototype, or let's say what we can call it a pre-production prototype for users to understand. So there we quickly reached that stage, and at that stage when all systems are getting integrated and we were finally doing user testing at their own home with the entire auto cook flow for that particular product, it is at that point that we found that a lot of concerns were coming, a lot of remarks and suggestions were coming from the user. The weighing system can be designed a little better, it can be positioned better, it can have a display better. These kind of remarks came at the design prototype stage where full user testing was happening. But it was so expensive to make that level of systemic design change at that stage, more than 1 year or 1.5 year into product development, that it required us a conscious decision to move away from the user feedback and do what is possible within business constraints rather than adapt and say that, okay, now user is asking this, let us try and fulfill that. We were not in a position to replan our project around that because it would make it unfeasible. It would shoot up the cost of the selling cost of the product by so much that it would not become a valuable proposition for our potential customer. So we had to take a call. That was an experience that taught me that no matter not how far your product is from being ready, our product can never be product perfect. It can be a component. It can be a component that you're doing for a trial. It can be a simple single component, or it can be a multi-part or multi-component product. We at whatever complexity, if it is ready or not ready, involving the customer is a good idea. But what I also learned is that it can become very difficult to explain to a customer everything that I have just explained to you.
Yeah,
We as
absolutely.
engineers will understand this pattern. We will understand that it will require evolution for a part to, like it will require these many attempts and trials and iterations to understand and make it better. But for a customer to understand and have that patience is very rare and almost non-existent. They will,
Yeah.
they will demand their rights because they are paying upfront. And in that sense, I think a lot of conversation needs to happen with a client or an end user to make them understand that this is not a problem as simple as they think it is. If we are not able to bring the user to understand at that level, then collaboration with that user is definitely going to become difficult, or it will at best give you a average output and definitely not a 99% level design for sure. In any scenario or case, it is going to be this way. It's what I learned majorly. And I'll tell you this, that in the RICO project, since we were talking about a project which was having more than 100 plastic injection mold, nearly 10 rubber mold, around 50 to 60 sheet metal parts which required to be laser cutted and bent in CNC bending machine. And it had electronic component, ceramic glasses, which were all getting imported from China. So such a complex project with like around 300, 400 components having to be assembled and built, tested and packaged and then dispatched to a consumer in India or US. It was definitely not a small exercise. So we even strategized out to involve the best EMS partners in India, available in India. So I am not allowed to name them here, but you can consider EMS partners on the lines of Foxconn that built iPhone, on the lines of Dixon that make
Okay.
refrigerators and air conditioners for Whirlpool and Samsung. They all do it within India. They all do box build. They do the tooling themselves, part manufacturing themselves, the embedded electronic PCB manufacturing, and the final assembly and integration also. So when we were working with them for over 1 year on developing this contract, just I'm not even talking about post beginning the contract or actual manufacturing. No, I'm only talking about the development cycle of it and collaborating with them to plan the project and establish a timeline, establish the commercial, and establish a pre-production ready design of the prototype. Just in that phase, when we were in discussion with the EMS, I realized that even if you have the parallel machinery required to produce or manufacture molds fast, if you have more injection molding machines that can produce parts parallelly, you can have 10 molds or running on 10 machine
Yeah.
producing parts. That does not assure you in any way that you are going to make a profitable product. It is not going to assure you that you are going to make a product that is going to click with the market and users are going to like it and word of mouth is going to spread and your demand volumes are going to go up. It does not assure you that just because we are going to make capital investment into tooling, that the product is ready for launch. That is not at all the criteria. It is not a criteria enough to have even the best vendor as your collaborator. You sign an MOU with them and you have locked on a contract with the pricing that is agreeable to our market selling point also. But there are so many details in the execution and production design and tooling and jigs and fixturing and assembly processes, quality control, quality management system, establishing even something as simple as today, everything is selling on Amazon, Flipkart, and our products have to go into their warehouses and our customer orders go on their platform. For us to be able to track a customer order with a given product that is outgoing from an assembly line, to be able to match the product batch number, component numbers, all of them require very well thought out processes are required to be developed. Depending on your product only, it has to be customized a little. It can't be like one key fits for all. It never is. It has to be changed and modified. And so these key takeaways are irrespective of the size or complexity of a product that we have to fundamentally, non-negotiably as business owners, be mindful of and be insisting that we have to keep all of this in check. Only then we can demand from our team that the best product be the one that launched into the market. If we don't insist on this ourselves, then we can't expect our team to do a miracle and produce something that is like a Maruti 800, which is product. Even today, if you see Celerio, it is essentially a modified, or a Alto K10 is a modified 800. Those kind of products don't simply happen in the market lasting for 20 years or more. For any kind of product, these kind of thinking and fundamental thinking is required, is my takeaway from Futuristic Labs. And so from there, now my venture that I'm wanting to do is essentially I have a philosophically philanthropic mindset. I really like to use my talents and my skills to give back to society as much as I can. But at the same time, I also need to be able to make enough revenue and money that I can live a comfortable life myself. Only
Yeah.
then can I have a mental space enough to support others. So to that end, I identified that the commodities or the consumable commodities in the agricultural segment is a very keen interest of mine, and mushrooms therefore
Yeah.
were
So
born out
yeah.
of that
So
idea.
now you could probably tell me this was your motivation for why you're currently with the Indian Shroom Company. You decided to take that leap. I feel like even the last learning lesson that you had that's about investing in a product, and there is a kind of leap of faith that you have to take with that product in the end. I think you're taking that leap of faith with this new venture. So tell me more about the Indian Shroom Company. What was your thinking? You just had just started talking about it. Just tell me more about what you think.
Okay. Indian Shroom Company, we actually are a 4-year-old startup now, and we are a very small team based out of Hyderabad. And what we are attempting to do is we are providing turnkey solution for any farmer or person who is interested to grow mushrooms which are edible and medicinal in value, not the white button mushroom that you get normally in market, but the more exotic variety like oyster or shiitake, reishi mushrooms. all these lion's mane mushrooms, all these new variety of mushrooms that people are getting to know of. We have been working for the past 4 years to develop an ecosystem of products. It is not a single product. It is an ecosystem of products which is required to enable a small team of maybe even 1 or 2 people to run a farm which can generate up to 1 ton of mushrooms per month. 1 ton or even more, depending on the
Wow,
setup.
that's a lot.
But it will require very net labor. It will require electricity and it will require clean water. But that's about it. And we have built an ecosystem of products right there because we have identified that our Indian farmers across multiple crop segments have very limited access to or awareness of available technology that they can use to streamline their operation and scale their volumes per month. In order to solve that problem, we took mushrooms as a specific challenge. It comes under the same domain of indoor farming or what we call as vertical farming nowadays. You can grow lettuce, you can grow coriander, you can grow spinach in vertical farm setups. Think of it very similarly, but this is not growing on water. This is growing on other substrates or medium like rice straw, paddy straw, which are agricultural waste. So what really made me attracted to mushroom is because I am by default, like you already know now, I am by default a polymer expert. I'm default tool designer, and I have a keen interest in material science a lot. So if you see mushroom, it's essentially a natural, like Mother Nature has created this organism, which is neither animal nor plant. It is neither non-veg nor veg. It is a fungus which essentially takes a raw material like paddy straw, rice straw, jowar, or even sawdust. It takes that material in that form and it converts into something called mycelium. And mycelium is essentially a fiber-like structure, which is purely fungus. So what it does is it takes all the phosphates and the nitrates that are present in these substrates and it makes it into more solid organic molecules. So when you grow mycelium, that same powder texture, it will be growing in a plastic bag. It will grow in a plastic bag or in a tray or in a glass bottle. So imagine if it's growing in a glass bottle with sawdust inside it, that sawdust from powder, it will become a shape of the jar only. It will become like the jar, but it will become like a solid. It will become like a brick almost. Okay. So what it does is basically that once you finish growing mushroom, then the waste that is there after growing mushroom, it almost becomes like that white color brick. And you dry that brick out, and it is essentially one of two things. It is an insulator and it is a packaging material. So you can think of it either as a construction brick or you can think of it as a styrofoam. The third thing that you can think of is fuel pellets. What we can use in barbecues or brick fire oven, you can use the wood pellets to fire them, right? Instead of that, you can use this as fuel also.
Are they
Rice
more
straw and
eco-friendly
paddy
in any way?
Yes, yes, very much. Because you've taken rice straw and paddy straw and you've grown mushrooms out of it. You've got like your mushroom required, you've grown it, and it now the soil is completely used up. When the soil is completely used up, it becomes like this brick. And then that brick is a material of so many possibilities. It is right as we speak. If you can just look up and research, there are already companies that exist that specifically do packaging based on mycelium. They only do mycelium packaging. They do mycelium packaging for wine bottles, for large appliances, for furniture, for these kind of one-time use packaging, which is required only for the transportation safety purposes that they use. And so it is lightweight. It costs lesser, and you can produce it in lower quantities. There is the MOQ is basically one. You don't need an MOQ of 10,000 or 20,000, which normally is the case when you're trying to buy any per packaging component like cardboard or PP bags or polypropylene bags or polypropylene packaging boxes or something like that, it'll be higher MOQ. But these kind of mycelium packaging, it is the low MOQ requirement. And the other application I told you was to use it as a construction brick. But I may have stretched out a little bit because it can be used for replacing kacha houses. Instead of building kacha houses, we can use these bricks to make pakka houses with insulation in them. It will stay cool in the summers and it'll stay warm in the winter. It has that effect and it has antimicrobial properties. So even during rainfall, there is no further formation of fungus or mold or anything like that. It will remain as it is. And third is being that it's being used for fuel as well. In my mind, as a materials guy, I could see so many applications of this thing, and all of them require the same fundamental process of growing mycelium. You have to grow mycelium in either a bag or you need to grow in a tray, or you can, if you're wanting to produce packaging, you need to grow it in a mold. You need to grow it in a literal mold. It will have a core, it will have a cavity, it will have two plates essentially, and you're placing the substrate inside and you're closing the mold and you're letting the fungus grow for 10 days. In 10 days time, your packaging material will be ready. So there is a lead time involved for packaging, but the whole point is that when scaled correctly, it will give you the cost benefit and the eco friendliness of the sustainable packaging that we call Mycelium to be. These are the reasons why I wanted to join Indian Shroom Company, and now we are hoping to provide these kind of turnkey projects where anyone wants to grow mushrooms, they can reach out to us and we will supply, install, we will commission the entire project for them with consultancy and also training program on how to grow these mushrooms using our equipment. In that sense, our equipment specifically, we have a patent pending equipment called the all-in-one pasteurizing machine. So it essentially it does soaking, it does steaming, and it also drains the substrate. It does three different processes in a single cylindrical drum. Earlier, these processes were traditionally done manually, soaking in a different drum, then bringing it out, spreading it out, drying it, and then putting it another chamber for steaming it. It would be a very manually laborious process requiring a much larger footprint for setting up the space. Now we can set up in a space as low as 800 square feet also. 800 square feet being the minimum, and we can have a setup as large as 2000 square feet. But something as large as 2000 square feet can produce like 5 tons per month. So a fairly large space.
Yeah, no, I didn't think of when I read up about the Indian Shroom Company, I didn't think that you were thinking of mushrooms as a mechanical material for these kind of bricks and packaging material and for fuel source and stuff like that. That's very interesting to know. You must be already doing these turnkey projects. Are you seeing more for the farming side of things, or are you seeing more of the material side of things?
Okay. So we in Indian Shroom Company kind of sits at the center of the supply chain. Our to our left, which is downstream for us, our downstream supply chain is basically having farmers with our setups who grow the mushrooms using our SOPs and our guidelines and our equipment. They grow these mushrooms. We buy it back from them. They don't have to have the hassle of thinking where to sell it. We buy the mushrooms from them also. We buy the spent mushroom substrate, what we call it, SMS, spent mushroom substrate.
Right.
That also we either buy it back from them so that we can repurpose them for packaging or fuel pellets or something else. But more importantly, the fresh mushrooms, which we should not forget. I spoke about the different applications of mycelium, but the fresh mushrooms themselves are the highest value in that whole setup. And we buy back the mushrooms from them that as our upstream supply chain, and we distribute it at various wholesale and retail businesses. As you see, mushrooms have a very short shelf life also. We are having to be those mediators because we can better control the supply and demand fluctuation, and we can channelize the incoming supply to the correct demand accordingly. And even if the mushroom does not get sold at the retail end or at the wholesale end, what we do is that we collect it back from them and we convert them into more value added products by increasing their shelf life. If you convert fresh mushrooms into something like pickles or powders or biscuits, then their shelf life increases from 4 days to 6 months or 12 months even. We also are looking to have tie-ups with pharma industries in Hyderabad who have a lot of demand for extracts of lion's mane mushroom. These are the kind of value-added products that we would be undertaking under our own shed, which then will be distributed again through the same channel under Indian Shroom Company as our brand. The thing is, we are now in a position where we can provide these kind of turnkey projects as a solution across India. But majorly, we are focusing Hyderabad and Telangana right now. We are having active projects in Hyderabad and we have in Orissa as well. But right now, our completed facility, we have kept a completed facility available as a demonstration for any interested farmer in Hyderabad itself. And it is in an indoor setting. We have kept it such that it is a direct replicable example for any urban farmer or rural farmer to keep a mushroom setup. Our headquarters is in Hyderabad, and we would be not only providing the installation services, but also giving you the right raw material, soil that is required, the seeds that are required, what we call as mushroom spawn that is required. Even that is something that we would be supplying. This encapsulates now our entire supply chain. We have to control this as a turnkey agency because mushrooms grow in a biologically controlled, like a lab growing setting. It is not grown in a open atmosphere. It is grown in a closed, controlled environment with very strict guidelines and very strict standard operating procedures. So, me coming from a background of manufacturing and quality and production, I am able to implement those kind of philosophies and procedures that are to be followed to keep and maintain the quality levels of the mushroom. Because like in manufacturing terms, defect rate was equal to how less or more a particular dimension got, or how less or more a particular surface roughness got. That was the key parameter there. In mushroom, the key parameter here is only contamination. How less contaminated your entire lab is. Is it at 97% cleanliness? Is it at 98% cleanliness? That's a huge difference. Anything lesser than 97 is technically impractical for growing. So you have to hit those kind of high levels of quality, high levels of cleanliness in order to keep it as a consistent production of mushroom. So it was an interesting challenge as a manufacturing and quality expert. I'm not applying it for plastics and alloys and materials, but definitely applying it for something like mushroom.
A more organic kind of
using
material.
philosophy. Yeah, it's still just applying it for an organic material. Yeah.
Yeah, this is very interesting, man. The kind of topics that we touched upon quite diverse in this. I think I'll if there's a link that you would want me to we should share with the people who view this video. I think you can send me that. I'm gonna link it in the description, and if anybody is interested, and I know a lot of people myself who are interested in this kind of vertical farming and these hydroponic farming setups as a passive kind of income stream. They invest in these kind of things. Yeah, very interesting. This is a I think worth looking at if you are looking at that kind of segment at all. And those kind of niche use cases that you're talking about in pharma, I think they have big business opportunities right there. So congratulations to you and your team.
Uh, Though I want to add here that we really see ourselves not as a monopolistic company. We very much want to replicate our model based on something like what Amul did or something like what Mother Dairy is doing as a cooperative. I'll give you a very simple statistic. I'll give you, which is the economic reason to why I am interested in mushroom. Is that right now the world business, or the let's say at the world global level, the total mushroom production that is happening around 80 to 85% of the total global production in metric tonnage, whatever metric tons it is, 85% of it is coming from China. And India is catering only to 1% of the global production that is. But we have all the other factors required. We have the right soil, we have the right population, we have the right amount of land, we have the right climate available for growing mushrooms, and still we are only at 1% of the global production volume. Definitely, I would be very happy through your channel and through your medium, whoever is interested to grow mushrooms, that they reach out to us. And we not only want to be it a solution where we sell and install you the system and we forget about it. We also provide financially feasible models, like even leasing models, where you can lease out the farm, have it as a passive income for you. We just use your space and your electricity, and the rest is on us. So we offer flexible
That's nice.
setups. So we can offer flexible setups where either complete ownership is with you, or we have a bipartisan ownership, or we have a complete ownership at our end, and we give you a cut based on what you bring to the table. So it is really a cooperative model that we are attempting to build here.
That's cool. That's cool. But congratulations to you and your team. Thank you for, again, Cassian, for doing this. This was really insightful.
Thank you so much. I would really like to do it again on any topic that you like.